Hey ladies, in this video we're going to go through 7D, which is sketching parabolas by completing the square. Scroll. So we're going to do the key ideas. Make sure that you put these, all your key ideas should go into your bound reference. So just kind of think, well, you know, you could be copying these down off the board, but they're in your textbook already. So you're encouraged to write these down. You already know how to complete the square. Well, you've learnt it. You did it in chapter 5. And we did do it a lot. And we also did it when we started chapter 7, when we did the booklet. We went through how completing the square puts your quadratic into turning point form. Okay, so you kind of have done this already. So it might be a good idea if you've forgotten it to go back to that booklet that I gave you at the end of last term to refresh your memory. I'm pretty sure these same key ideas are in that booklet. So when it's in this form, y equals a times x minus h squared plus k, we can read off key features. So in 7C, we looked at factorizing or using factorization to sketch parabolas. And that's good because we get the x-intercepts, we can get the y-intercept, and then we also use the x-intercepts to get the turning point. When it's in turning point form like this, and to get it in this form we complete the square, you can see some key features straight away, and they're different key features. So HK, so your H here and your K, they're the coordinates of your turning point. So H is the coordinate of your it's the x coordinate of your turning point, and k is the y coordinate of your turning point. And when you think about it, and we've covered this before, so it's not new to you, h tells you how your graph has moved left or right. Okay, so your x value is changing, and k tells you whether you've gone up or down. So that's your y value changing. Now a, when it's positive, you have a minimum turning point. So I'm going to draw this here just so you know. So when A is positive, your parabola looks like this. So this is your turning point here, okay? So turning point just means we're changing direction. So we're going down, 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 turning point, up, 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 up. Okay, so that is what we call a minimum, okay? Because it's at the bottom. And when A is negative, so this is when A is positive, and when A is negative, you have an upside down parabola. So here's our maximum point. Okay, and so this means we're going up, 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 turning point, down, 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 down. Okay, so minimum when A is positive, maximum when A is negative. So as soon as you see your value of A, doesn't matter whether it's just negative, or if it's -2, -100, or positive numbers, you should know straight away what is happening with your graph. Okay, so if it's a positive, it's a positive parabola, and you have a minimum turning point. If A is negative, you have an upside down parabola, and you have a maximum turning point. Now, A also tells you whether it is made wider or narrower. And what I mean by that is that means it becomes wider, okay? And that means A is between 0 and 1. And it becomes narrower when A is greater than 1. And you went through that in the booklet as well. So when A is greater than 1, and it could be negative or positive. So it could be A is less than -1. Okay, and then it just becomes a narrow upside down parabola. So when I refer to 1 and between 0 and 1, that just means the number, and it could also, the sign, a positive sign is a positive parabola, negative sign is a negative parabola, so it has a minimum if it's positive, maximum if it's negative. All right, what else have we got here? To get the y-intercept, we let x equal 0. So before, when we're doing factorization, I would say that your y-intercept is just your constant value. In this case, you can't just assume that, because k even though it's a constant, you've got all this other business going on which would affect that. So just let x equal 0 to get your y-intercept. Don't assume that it's just your value of k. And to get the x-intercept, we let y equal 0. Now remember, we're not always going to have x-intercepts. We could have 1 x-intercept, we could have 2, or we could have no x-intercepts, and that means it's gone above or below the x-axis. And you've done solving for y equals 0. You've done all this back in chapter 5. We're now looking at how it relates to the graph of a quadratic, which is a problem. What have we got next? To solve x squared equals a, where a is greater than 0, take the square root of both sides. Now, this is just a reminder. When you are solving, okay, so here's an example. So if we've got x plus 1 squared equals 16, to get x plus 1 by itself, or to get rid of that squared sign, we take the square root of both sides. And when you take the square root of a number, you get both a positive and a negative answer. Okay, so the square root of 16 is positive 4 because 4 times 4 is 16, but it's also negative 4 because negative 4 times negative 4 equals 16. And that's why we will often see 2 x-intercepts. Okay, so that'll probably make more sense when we do some questions, although we did cover this earlier in the booklet that we did at the start of the chapter. Okay, let's scroll and do some questions. So all those examples here, you know, in your online textbook, there's video solutions of them. So if you want someone to talk you through them, they're on your online Cambridge site. Each question also has an example next to it, so you can go back to it or you can watch it. If you're using your online textbook, you can just click on it and it takes you straight there, which is pretty awesome. Okay, let's get rid of all this and do some questions. Okay, let's start off with question 1, because I think sometimes I start later and students still need help with the very first question. So let's have a look at this one here. All right, so when I look at this, I can tell already so much information, and that's because I'm experienced with quadratics, and eventually you'll get to this point. So I can see that this negative means it's a negative parabola. The 3 means it's become narrower. This 2 means it's moved to the right 2, and this 3 means it's gone up 3. Okay, so they're the 4 things that I can tell just by reading that. Okay, so let's actually answer the questions. Okay, question A, determine the coordinates of the turning point and state whether it's a maximum or a minimum. So here's H and here's K. So your turning point, which I'm just going to call TP, is 2, 3. Now this negative sign, it's not negative 2 because our general form in turning point form, oops, should be an A, already has that negative there. So this, if it helps, you can write everything except for A, H, and K in a different color so you can see, but you'll pick it up. Okay, it can be a little bit confusing to begin with, but you'll pick it up that H is just what that value is here. Okay, and that that negative there doesn't refer to H. Okay, it's a part of the turning point form. All right, and it's a maximum. Okay, because of this negative sign. Okay, that negative makes it maximum. It looks like this, what I've drawn here. Determine the y-intercept. So the y-intercept is when x is equal to 0. So I'm just going to scroll down a bit so we've got a bit more space. -3, 0 minus 2. So I'm just substituting this into the equation. If you're wondering where these numbers came from, there's our equation. Okay, so -3, got -2 squared, so it's going to be 4. So y equals -3 times 4 is -12 plus 3. So your y-intercept is at -9, or y equals -9, if you want to write it as coordinates 0, -9. What else have we got? And the x-intercepts. So your x-intercepts, first of all, you got to think about, well, what's happening with our equation? It's a negative parabola that's gone up 3, so it does have x-intercepts. If it was a positive parabola that's gone up 3, it wouldn't have any x-intercepts. So that's why it's important when you look at it, look at your quadratic in turning point form, you understand what it's doing. Okay, so let's find out x-intercept. So we let y equal 0. Okay, and this we did in chapter 5. So your x-intercepts when y equals 0, so we're just solving this. So I'm going to bring this over to the left-hand side, multiply both sides by 3. So that, oops, not multiply, sorry, divide by 3. Why did I do that? Okay, so that cancels out. So we've got x minus 2 squared, I'm going to run out of room, equals 1. So get rid of that squared sign. Might just write over here because I don't really want to grab another page. So we're going to have x minus 2 equals the square root of 1. Now, remember this, when you're taking the square root, you get a positive and a negative. So we're going to have x minus 2 equals positive 1, x minus 2 equals negative 1. So your x is equal to negative 2. Sorry, when we bring that negative 2 over, it's going to be 1 plus 2, which is 3. And then bring it over as a plus, so it's going to be 1. Sorry, it's a bit small there, but there are our x-intercepts. So we've got 2 x-intercepts. Remember that the turning point is halfway between those two. So we can see that is at 2, which is good. Yeah, there's your y-intercept, and we had our turning point before. All right, let's clear all that. I might actually, oops. Okay, so Word just wanted to die on me, so I just start again. It's a good thing I wasn't doing anything too important. Okay, so we've done question 1. Let's just have a look at question 2. So state whether the turning points of the following are a maximum or a minimum and give the coordinates. So we're only looking at the number in front of the bracket. Okay, if it's a positive, it gives you a minimum. If it's negative, as it is with question B, it gives you a maximum. Your turning point is going to be H. So in the case of A, it's 3, and K. So in the case of A, it's 5. So let's have a look at doing a positive. Actually, I'll do, what will I do? I might do D, because D is slightly different, and this can be confusing for some students. So y equals 6x plus 2 squared minus 5. Now remember, the general form of a quadratic in turning point form is that, okay? But we've got a positive here and a negative here. Sometimes it helps to rewrite this positive as negative, negative. So your value of h in this one is -2. And here we've got plus -5. So your value of k is -5. Sometimes a little bit easier to identify k, but students have a hard time understanding, well, if this is a plus, isn't h positive too? Well, no, because your general form has the minus here already. So it's x minus -2, making h -2. Okay, so if you see a plus in between, I always encourage students to write negative, negative, so you can see that h is -2 because our general equation has that negative already there. So this quadratic has gone to the left 2, or in the negative direction 2, and it's gone down 5. The 6 means it's become narrower. We don't have to do that, but just so you know, and it's positive parabola because the 6 is a positive number. Oh, someone's just joining us. Let's see who it is. Oh, it's Mr. Souza. She must be in here next period. Okay, let's have a look at doing some more questions before we get trampled on by some other students. Determine the y-intercept of each of the following. Okay, so we've done in question 1, we let x equal 0. Yes, x equals 0 for your y-intercept, so you should be fine with that. The x-intercepts, now it says if any, so I might just tell you when we're not going to get x-intercepts. So if you have a positive parabola, which is this, that's gone up, you're not going to have x-intercepts because your general form of a parabola sits at 0, 0, or your what we call the basic parabola, which is y equals x squared. So if it's moved up, it's no longer crossing your x-axis. So I can see in question 4 which ones won't. So A will, B will, C will, D will, E will, and I'll explain that negative one in a sec. F will, G will. G and H will only have one. They'll actually be on the x-axis. Now I won't. I is a positive parabola that's gone up 18. Okay, so it's not going to have any x-intercepts. J is a negative parabola that's gone down. Okay, so that also won't have any x-intercepts. I'll explain that in a second. K will and L will. Okay, so if you have a negative parabola, let me quickly show you. Okay, so here's our, that should be sitting on at the origin. So we've got a basic one. Now, if that's been moved down, okay, you can see it doesn't cross your x-axis. So we have a negative parabola that's gone down. It also won't have any x-intercepts. Now, if it's only gone left or right, not up or down, you're going to have one x-intercept. And that's what I meant by G and H. You can see G has moved. It's gone to the right 4. H has moved to the left 6, but they haven't gone up or down. So you only have one x-intercept for them. Okay, let's just see if there's any other questions that I can quickly do. Actually, I think I feel like I've done enough. If you're having trouble with completing the square, there's videos on completing the square, which I might link into this document. Otherwise, you can ask for help in class. All right, bye girls.